Good morning, Year 4. Welcome back to our maths lesson. I hope you enjoyed the first day of home learning yesterday. And I was really impressed with everything that I saw on Seesaw with our 9 times table lesson yesterday. Some of the reasoning was fantastic and how you applied your times table. So I really hope you enjoyed the lesson. We're going to be moving on to our 7 times table today. But quickly, I just wanted to go over our little trick that we learned for the 9 times tables. Hopefully you managed to watch the video and learn the little finger trick. So we're just going to recap how to do that now. So I want you to put down your 5th finger so that we can find out 5 times 9. So I've got 4 on this side and 5 here. So 5 times 9 is 45. Okay. Can you now put down your 4th finger? So on this side, I've got 3. On this side, I have 6. So 4 times 9 is 36. Well done if you got that one. Now, see if you can do one without me. Can you do 8 times 9 on your fingers, please? So putting down your 8th finger. 8 times 9 is, let's check. So I'm going to put down my 8th finger. I should have had 7 and 2. 8 times 9 is 72. So well done if you managed to get that. If you didn't manage to watch the video yesterday, please go back and have a look because it's a really fantastic way of helping you remember those 9 times tables. So moving on to today's lesson, we're going to start with our do now. Now, very similar to yesterday, we're going to be looking at multiples again. Now, remember, multiples are numbers that are in that numbers times table. So yesterday we did the 3s. This time I would like you to look for the multiples of 4. So which of the following numbers are multiples of 4? So remember, you may be able to spot some patterns with the numbers that you know in the times tables up to 12 times 4. And then you may need to use some other ways of working them out. So if you want to use bus stop to help you, that's absolutely fine. But see if you can have a look at those patterns and think about the numbers that we used yesterday for the 3 times tables. Okay, pause the video when you're ready, off you go, and then come back for the answers. Okay, hopefully you've managed to have a go at that. I'm just going to share my screen with the answers. So you should have got 64, 452, 12 and 940. So well done if you managed to figure those ones out. You may have noticed 12 is also in the 3 times tables, which we should know because it's a common multiple because 3 times 4 is 12 and 4 times 3 is 12. So moving on to today's lesson, we're going to be looking at representing facts in the 7 times table. Now, personally, I think the 7 times table is one of the trickiest ones because it doesn't really follow many patterns, but we're going to have a look at it on our number line first and see if we can use our known facts again to help us work it out. Now, please do follow along. I'm going to pause and give you some time to think about the questions. So look really carefully and think about what I'm asking. So we're going to start with, obviously, at the bottom of our number line here, we have 0 times 7, which is 0. Because 0 times any number, we're always going to get 0. My first fact is 1 times 7, which hopefully we'll all know is 7. 2 times 7 is double 7. Double 7 is 2 times 7, 14. Then obviously I've got 2 times 7. I can double that number again to get 4 times 7 because double 2 is 4. You may know your 4 times tables really well as well. But if you don't, then I can definitely do double 14. So double 10 and double 4. I'm going to double that and add it together. So 4 times 7 is 28. Well done if you managed to get that one. Now, I should know my 5 times tables really well, but I know my 10s probably is the easiest. So I'm going to jump straight over to my 10 times. So 10 times 7 is 70. Now, remembering what we looked at in our 9 times tables yesterday, to find 9 times the number, I can subtract one multiple. So I'm going to do 70 take away 7, because it's my 7 times table. So 70 take away 7 in your head, 63. You may have remembered that from our times tables yesterday, so well done if you did. Now, I'm going to jump back down to my 5 times tables, because now that I know 10 times 7 is 70, I can half that to find 5 times the number, because half of 10 is 5. So half of 70, or 5 times 9, half of 70 in your head, is 35. Well done if you managed to get that. So I'm going to jump back down to my 3 times tables now, because I think this one I can definitely work out. So you may know your 3 times tables really well. But if you don't, then hopefully we can do our 2 times tables and then we can add on. So 14 add 7 is 21. Well done if you got that one. Now, jumping back up to 6, 7 and 8 times 7, I think these are quite tricky ones to work out, but we have been practicing this times table, our 6 times table, so you might know 7 times 6 already. However, I know that 6, I can use my 3 times tables to help me, because double 3 is 6. So if I double 3 times 7, which is 21, that's going to give me 6 times 7. So double 21, double 20, and double 2. In your heads, what is double 21? Double 21 is 42. Well done if you managed to work that one out. So now I've got 6 times 7. Then to find 7 times 7, well, we have practiced our square numbers before. 7 times 7 is a square number because I'm multiplying the number by itself. But if I'm not sure, I can just keep adding on. So 42 add 7 is 49. Okay, the next number is the 8 times tables. Now, again, we have practiced the 8 times tables last half term, but if you're not sure, I can subtract from 63, or I can add on to this number to help me find it. But there's also another fact that I should be able to use to help me, because half of 8 is 1, 2, 3, 4. So again, I can double my 4 times table number here to help me get to 8. So double 28, if I do double 20, that gives me 40. Double 8 is 16. 40 add 16 is 56. Miss Jones made a very silly mistake there. So 56 is the next answer. So please do pause if you need to, and you can practice counting your 7 times tables, and then we can come back. So moving on, what do you notice about the 7 times table? Well, as I said before, there isn't really any patterns that the 7 times tables follow. So that's what makes it quite a tricky times table to remember. Because if you notice, all of the ones digits are different. So it's a bit tricky to remember in any pattern. However, you do know other facts, as we just looked at, to help you if you get a bit stuck. The ones that we do find quite tricky are these ones here. I do notice on TT Rockstars, those are the ones that were taking a long time to answer. So we do just have to try and remember those. So moving on, we're going to start looking now at different representations. I want you to look at the representations on your screen. So I have an array here. We're counting on in groups. There's lots of different representations. I want you to think about what's the same, what's different about them, and which one is the odd one out. So I'm giving you a little bit of a clue there. So I want you to pause your screen in a moment and have a think about those questions. Off you go. Okay, hopefully you've had a chance to think about those. So you may have noticed, obviously my array is representing 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7. So it's 5 groups of 7 or 7 groups of 5, which is what my representations over here represent as well. So I've got 7 lots of 5 and repeated addition, and then I've also got 7 repeated 5 times here, the same as 5 times 7 and 7 times 5, because if I put them together, they're both going to give me the same answer. They're commutative, which means that it works both ways, which we have been practicing. There was one odd one out, which you might have noticed, was this one here, hopefully. Because if I count the number of groups, I've got 1, 2, 3, 4, 5, 6. So it's 6 lots of 7. So that doesn't match the times table that these ones were representing. So on your screen now, there are some different representations like we've just looked at. I want you to pause in a moment and think about which ones are representing the same times table. Which ones are similar? So can you pause your screen now and have a think about which ones you would group together? Off you go. Okay, well done. Hopefully you've had time to think about which ones would fit together. So you may have noticed we've got 3 times 7 and 4 times 7, 7 times 3 and 7 times 4. So some were representing the same times table. So you may have been able to group them into 2 groups like this. So there's lots of different ways that we can represent the times table, and it's still going to give me the same answer. So I can use my arrays, I can use a bar model, I can use repeated addition, grouping, and obviously the standard way we represent our times tables that we're used to. So we're going to have a look now. There's some different equations on your screen. I'm going to show you how to do one, and then we're going to go away and have a go. Now, it might be a bit tricky. You might not have lots of equipment at home. Obviously, you don't have the usual maths concrete things that we use in the classroom, but you might be able to find some interesting things around your house, and I'd be really interested to see on Seesaw what you can come up with. So I'm going to first have a look at 7 times 6. I'm going to pop on my visualizer. I've started to get this ready here, so I've done an array. So I've got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So it's showing me 6 times 7 and 7 times 6. I've also drawn a bar model. So I've got 1, 2, 3, 4, 5, 6. So if I put a 6 here, surely that must show me 6 times 7 and 7 times 6. Oh, can you see what I've done wrong? What number should be here? 1, 2, 3, 4, 5, 6. Hopefully you're shouting at the screen now saying, silly Miss Jones, that one should be a 7 because there are 6 groups and each one is representing 7. I could also represent this on a number line. I might do 1, 2, 3, 4, 5, 6 jumps. And if there's 6 jumps, remember I'm showing 6 times 7 or 7 times 6, each one would have to be 7. 7, 7, 7, 7, 7, 7. I could also do 6, add 6, add 6, add 6, add 6, add 6. 1, 2, 3, 4, 5, 6. Oh, I need one more. So that's 6, 7 times 6 groups of 7. Okay, so you could do some pictorial representations, or you might want to find some objects around your house to help you represent. Here's one I made earlier. So I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Each group has 7, and there are 6 groups. 7, 7, 7, 7, 7, 7. So that's another way I could represent 6 times 7 or 7 times 6. So I'm going to pop the screen back on to our equations. What I would like you to do now, you could do the same one as me, but see if you can have a go at one of the other equations. Could you go away? And if you've got something in your house to write it down on, or to take a picture, if you find some concretes that you can make with objects to show your equation as well, that would be fantastic. I'm going to give you some time to do that. So pause the video and then come back, and then we will move on to the next part of the lesson. So pausing your video now, choosing your equation, off you go. Okay, welcome back. I hope you had some fun doing that. I can't wait to see your representations later. Let's move on to the next part of the lesson. So we're going to look at fact families now. Now you may notice the numbers here look a little bit different to what's in my 7 times tables that I'm used to. So I've got 60 and 420, but we know that we can use our known facts to help us. So I'm going to be doing 2 times facts and 2 division facts to create my fact family. Now we did look at this yesterday as well, using our arrays for our 9 times table. So hopefully you're familiar with this. So I'm going to start with the ones that I know. So I know 7 times 6 is 42. It's not going to be 420. So I can create my first fact. And then it works both ways. Remember, it's commutative, so 6 times 7 is also 42. Excuse my bad handwriting. Then I'm going to do the division. So remember, if I'm doing division, I need to start with the whole. So I'm going to start with 42 divided by 6 equals 7. And 42 divided by 7 equals 6. So that is one fact family I can create from these numbers that I have given you. Okay, we're using these ones here. I'm not going to make up my own. I just want to use the cards that are in front of you. So I'm going to now look at what my other facts are. So I know the whole here is going to be 420. And I'm obviously multiplying it by 60 because it's 10 times bigger. So I need to think now which number is going to go here. Now I'm not going to use the 6 because I know 6 times 6 is 36. That's not going to give me 42. So it must be 7 times 60 is 420. So similarly, 60 times 7, it's going to give me the exact same answer, which is going to be 420. So I'm going to create my division facts now. So I've obviously got to start with my whole, which is 420. Divided by 60. So the first number that needs to go here is 7. And then 420. Remember, always starting with my larger number if I'm doing my division here. Divided by 7 equals 60. I don't know if you managed to get that. Right, we're going to have a go together now. I've shown you what you're doing. So let's have a look at the next slide. So this time you've got 30, 210, 7, 840 and 120. So a little bit tricky now. So what I would like you to do is pause the video and see if you can work out your fact families from this group of cards. So pause the video, off you go, and then we are going to have a look together. Okay, so let's have a look. So the ones that I can do in here that I already know, I definitely know I've got 7 there. And I've got 30. So I know that 7 times 3 is 21. So these ones must be linked together, but it's 10 times bigger. So I'm going to say 7 times 30 is 210. So I can use my known fact of 7 times 3 is 21. So I can also do 30 times 7 equals 210. Well done if you managed to get those ones. So now I just need to do my division fact. So 210 divided by, I'm going to go with 30 first, equals 7. And 210 divided by 7 this time equals 30. So well done if you managed to work out those. Now, you may notice we were looking at our 7 times tables before, and there's a number that's a little bit bigger here. I know 10 times 7 is 70, so I know 11 times 7 is 77. So this fact must be something to do with my 12 times tables. So I know that 7 times 12 equals 84. So 7 times 120 must equal 840 because this is 10 times bigger. So my answer also needs to be 10 times bigger. A little bit tricky, that's a well done if you managed to work that out. So my next fact is going to be 120 times 7 equals 840. And then moving on to my division, remember my larger number needs to go first, my whole, so 840 divided by 7 equals 120. Ooh. And then I need to do 840 divided by 120 equals 7. Well done if you managed to work those out. Much trickier on this side that time, but well done if you managed to get these ones. So we are going to move on to our independent test now. You will notice on question number 1, you are creating the fact families for there. So I'm expecting to see 2 fact families like we have just done together for these cards. Then if you notice, you've got some similar questions to yesterday, but doing your 7 times tables today. Some of us found this one a bit tricky yesterday with the negative numbers. Remember, it's going backwards, so write out your 7 times tables to help you. And then you should be able to work out this using those facts. And I can count on this one using my 7s. When you get to the reasoning, I've put a few challenges in the reasoning, but see if you can have a go at least one or two of the questions. If you're finding these ones a bit tricky, don't worry, we'll be posting the answers as well, so have a look at that to help you. I have put those on just as extra challenges for those of you who want to stretch yourself onto that, but do have a go and do your best. So I can't wait to see all of your work on Seesaw again. Really well done. Keep practicing your sevens. Go back and write them down and practice chanting them. Get someone to test you before you go off and do your independent task if you can. So good luck, enjoy, and I will see you all tomorrow. Bye, everybody.